This is OpenGL Programming Guide, OpenGL version 2. This is OpenGL Programming Guide, OpenGL version 5.4. I read these two books simultaneously. I read both of these two books. One is older version, the other is latest version. Mathematical Elements for Computer Graphics Second Edition. This is my first book about computer graphics. This book was published 1990. I purchased this book around 1992 or 1993. This book is wonderful. This book deals all the mathematics I wanted to know about 3D computer graphics.
Hi everyone, my name is Thomas Kim. Today is September 8th, 2020. This is my 47th episode about vector calculus and classical electromagnetism. Also, this is my 4th episode about OpenGL graphics tutorial. In this episode, I will discuss 3D graphics fundamentals or fundamentals for 3D graphics. I will also discuss how to run a new computer technology more effectively. When you learn a new technology, always try to understand how the technology has evolved over time. For example, if you try to learn up-to-date C++ language, you basically have to understand C language, then C++ 98 standard, C++ 11 standard, then C++ 17 up to C++ 20 standard. But don't make a silly mistake as to dwell in the past. New technology emerges to solve new challenges that we cannot handle efficiently with our existing old technology. Don't love too much what you already have or what you already know well. For instance, you've learned C language and you love your C language knowledge too much that you have no room in your heart and mind to accept new technology, which is to solve both old and new challenges more efficiently and effectively. I read OpenGL version 2 to understand the fundamental working principle behind this technology. Now, I think I understand how it works. I move to the latest iteration of OpenGL, version 4.5 or 4.6. If I haven't read OpenGL version 2, it is very likely that I failed to understand the latest OpenGL version 4.5 or 6, let alone Vulkan. I will remind you once again, do not dwell in the past. OpenGL version 2 is the past. OpenGL version 5.4 or 6 is the current. Vulkan is the future. Leave room in your heart and mind as to embrace new theories and technologies. I would recommend these books. For example, Mathematical Elements for Computer Graphics. Please double-click this link. From this website, you can purchase second-hand book. This one is less than $2. This is less than $3. You can purchase one of these second-hand books. For any programmer who are interested in serious 3D computer graphics, this book is must read. Also, when you read a book, read it from cover to cover. Suppose you are an author of a book. You want to put as much knowledge as possible into your book. If the book consists of two parts, part 1 is for basics to introduce more advanced technology. In part 2, by reading part 2, you can solidify your understanding of part 1. Usually, part 1 is to introduce the fundamentals. To understand part 2 of the book, almost always read the whole book from cover to cover, not missing any part of the book. Without further ado, let's get started. In episode 43, we learned how to use OpenGL on Windows for the first time. If you haven't watched this video, please watch it. In episode 44, we learned the concept of scaling factors and translation factors mathematically. If you haven't watched this video, please watch it. Understand what is scaling factors and translation factors. It is simple mathematics. If you learned second grade middle school mathematics, you should be able to understand what is scaling factor and translation factors. Then, in episode 45, in this video, we learned OpenGL primitives and we applied scaling and translation factors to draw two-dimensional graph. And in episode 46, we learned how to use translation and scaling metrics. If you haven't watched my previous episode, episode 43 through episode 46, you probably cannot understand my current session. Now, we go back to our previous episode. In our previous episode, we learned the concept of scaling factors and translation factors. Now, let me remind you what we learned in our previous episode. For 2D graphics, scaling factors and translation factors are good enough. But for 3D graphics, we need projections. There are two kinds of projections. One is perspective projection. The other is orthographic projection. I will explain both of them. Now scroll up. This is OpenGL viewport. So coordinate in OpenGL viewport, we say viewport coordinates. In this graph, this is our model. Our model can be a cube like this tool. This model is represented in model space or model coordinates. In our previous episode, we dealt with a two-dimensional graph. Now we will deal with three-dimensional model, such as a cube. Now scroll down. In two-dimensional space, XO, the coordinate in OpenGL viewport, is represented as x times x plus tx. YO, y coordinate in OpenGL viewport, is represented as y times y plus ty. Now we expand to 3D. ZO, z coordinate in OpenGL viewport, sz times z plus tz, where x, y, z is the vertex of our model, such as a cube. This is our model. X, Y, Z represent one vertex in our model. Now we can expand this system of equation like this. x0 equals sx times x plus 0 times y plus 0 times z plus tx. yo equals 0 times x plus sy times y plus 0 times z plus ty. z0 equals 0x plus 0y plus sz times z plus tz. Now we represent this system of equation as a matrix. xo, yo, zo equals sx 0, 0, tx 0, sy 0, ty 0, 0, sz, tz, x, y, z. This matrix 1, 2, 3, 1, 2, 3, 4. So 3, 5, 4 matrix. This matrix 1, 2, 3 and 1 column times 3, 5, 1. This matrix operation obviously does not work. The column count of this matrix and the row count of this matrix does not match. We cannot represent this system of linear equation as a matrix of this form. We cannot. To overcome this problem, we introduce W like this. x0 equals sx times x plus 0 times y plus 0 times z plus tx y0 equals 0 times x plus sy times y plus 0 times z plus ty z0 equals sz times z plus tz. Now we introduce w equals 0x plus 0y plus 0z plus w. I will denote it w0. If we form matrix, it becomes x0, y0, z0, w0 equals sx 0, 0, tx 0, sy 0, ty 0, 0, sz, tz 0, 0, 0, 1, x, y, z, w. Now this matrix 1, 2, 3, 4. So 4 by 1, 2, 3, 4. 4 matrix times 1, 2, 3, 4, 4, 5, 1 column. So column count of this matrix, row count of this matrix matches. We successfully represented this system into matrix by introducing WO, W. Such representation is called homogeneous coordinate system. Now scroll up. I will represent this matrix by F equals F is this matrix, transformation matrix, Sx 0, 0, Tx 0, Sy 0, Ty 0, 0, Sz, Tz 0, 0, 0, 1. And I will let matrix S, Sx 0, 0, 0, 0, Sy 0, 0, 0, 0, Sz 0, 0, 0, 0, 1. And the matrix T like this: 1, 0, 0, Tx 0, 1, 0, Ty 0, 0, 1, Tz 0, 0, 0, 1. Now I scroll up. We operate transformation matrix F T times S, where T is this matrix, S is this matrix. This equation holds true, but S times T is not equal to F, because S times T is not equal to T times S. As I mentioned in previous episode, episode 46, Please watch this video. In this video, we learned that we have to apply translation matrix prior to scaling matrix. In this representation, matrix X is scaling matrix. This matrix T is translation matrix. Transformation matrix F equals translation matrix times scaling matrix, but not scaling matrix times translation matrix. Please double check this fact by watching our previous episode 46. In the homogeneous coordinate system, as in OpenGL library, if you specify GL vertex 3F 1, 2, 3, then internally it generates vertex 1, 2, 3, 1. This one is for W. If you specify GL vertex 4F 2, 4, 6, 2, then OpenGL internally generates vertex 1, 2, 3, 1. 1 is for W. If you specify GL vertex 4F 4, 8, 12, 4, then OpenGL internally generates 1, 2, 3, 1. In a nutshell, all these representation generates the same coordinates. That is, if you specify GL vertex 4F X, Y, Z, W, OpenGL generates X over W, Y over W, Z over W, 1. Such coordinate representation is called normalized device coordinates, or NDC. Now scroll up. In this matrix, this element, all these elements does not change. These elements are constant. In the same manner, in translation matrix, this element are constant. So, if we specify GL scale F SX, SY, SZ, OpenGL internally generates SX 0, 0, 0, SY 0, 0, 0, 0, SZ 0, 0, 0, 0, 1. This scaling matrix. In the same manner, if you specify GL translate F, TX, TY, TZ, then OpenGL generates 1, 0, 0, TX, 0, 1, 0, TY, 0, 0, 1, TZ, 0, 0, 0, 1. This is scaling matrix S. This is translation matrix T. I highly recommend you to watch my previous episode 46, OpenGL Graphics Tutorial 3, and double check what we learned in this episode.